Hi, and in this video I'll be describing the difference between the two different algorithms that you can use to undertake low-resolution, large molecule charge state deconvolution in the Discharger tool in the AutoVectis suite. These two algorithms are called Flasher and Dasher. Flasher undertakes deconvolution using a Richardson-Lucy type algorithm in the same manner as UniDEC, but sprinkled liberally with some AutoVectis magic pixie dust. Dasher is a maximum correlation deconvolution algorithm with a flying moth optimization stage. Dasher is extremely fast, but it is dependent on there being a single charge state series within your spectrum and where all the charge states must be resolved. On the other hand, Flasher is a more generic algorithm. But while still fast, it won't quite match the speed of Dasher because it's solving a more difficult problem. So let's see them both in action. So starting with the AutoVectis splash screen, to start Discharger you just have to click on its icon. And that will open up the Discharger screen. Now in order to demonstrate the capabilities of Flasher and Dasher, I'll open up a spectrum of an antibody sample. Normally in Discharger, you'd now zoom to select the region of the spectrum that you want to deconvolve. But in this case, we'll just deconvolve the entire spectrum. And you can see from this control, we'll be using the Flasher algorithm, that's the Richardson-Lucy deconvolution, for this first run. So now we've opened the spectrum, we've chosen the mass range in the spectrum we want to deconvolve, and we've selected the deconvolution algorithm to use. So to undertake the deconvolution, you just click the deconvolve button. My system is running a little slower than usual because of the screen capture process, but even so the Flasher algorithm only took 3.8 seconds to produce a cleanly deconvolved spectrum. We'll zoom in a moment to look at the detail, but just now I just want to highlight that Flasher has returned a solution for the entire user-selected mass range from 100,000 to 200,000 Daltons. And that was defined by these two controls over here. And before we zoom into the detail, let's change the deconvolution algorithm to Dasher and reprocess the same input spectrum. This time you'll note that Dasher has returned results in a much narrower mass range. And that's because Dasher only returns the spectral range that exhibits the maximum correlation between charge states. But you'll also have seen that Dasher deconvolution took less than 0.4 of a second, and so in this case it's an order of magnitude faster than the Flasher algorithm. So now let's zoom in and compare the output from the two different methods. In this view, we're still looking at the output of the Dasher algorithm. The green line is the raw deconvolution output, and the blue line is the wavelet decomposition of that raw output. Now if I keep the view the same and change back to the Flasher algorithm and then reprocess the spectrum again, if you watch carefully you can see the difference between the results of the two algorithms. But as you can see, the differences are really minor and both are producing essentially the same result. So again, if I change back to Dasher mode and reprocess, you can look to see if you can spot any of the tiny changes. So because the differences are really subtle, let's look at them in a little more detail. Here's the result of processing the data by the Flasher algorithm. And here's the result of processing the same data by the Dasher algorithm. And here I'm showing the wavelet decomposed spectra produced by both methods. What this shows is that both algorithms are capable of producing basically the same output. And so for the majority of spectra, that is those spectra where the charge states are fully resolved and there's only a single charge state series in the spectrum, I would recommend using the Dasher algorithm because it's considerably faster. But now let's look at a spectrum where you need to use the flasher algorithm. Back in Discharger, let's open up a file that contains a much more complicated spectrum. As before, this is a mass spectrum of an antibody sample. But in this spectrum, there are peaks that come from the antibody monomer, and over here we can see a set of peaks coming from the antibody dimer. Because we now expect the deconvolved spectrum to include the peaks corresponding to the antibody dimer, we'll need to increase the upper limit to the mass range. And now we can deconvolve this spectrum using the flasher algorithm. And in the results here, we can clearly see the peaks corresponding to the monomer and the dimer. So now let's see what happens if we reprocess the same spectrum with the Dasher algorithm. Because of the way Dasher's maximum correlation algorithm works, it will only ever return one region in the final result. But if we zoom into the detail, we can see what happens when it tries to fit two different charge state distributions into the same mass space. So now compare this result to what we get when we process the same spectrum back in the flasher algorithm again. So when you have a new set of sample data to analyze, it's worthwhile using the flasher algorithm to check one file to see whether it contains only a single charge state distribution and where all the charge states are resolved. And in that case, you can probably go on to use the faster Dasher algorithm to process the rest of the dataset. On the other hand, if your data is more complicated and includes multiple charge state distributions, or where the charge state distributions are partially overlapping, then you will need to use the flasher algorithm, which, although it will be a little bit slower, is more capable of dealing with these complicated spectra. So to recap, the large molecule low resolution deconvolution tool in the AutoVectis suite is called Discharger, and it offers two different algorithms for charge state deconvolution, known as flasher and Dasher. Choosing the right algorithm will give you the best compromise between speed and coverage. Finally, some of the development work for these algorithms was supported by the TopSpec grant that was part of the EU's Horizon 2020 programme, and we're extremely grateful for that support. I've added a link to the main TopSpec website in the information below, and you can go there to find out more about this groundbreaking project. If you want to find out more about Discharger or the wider AutoVectis suite, or you want to try it out with your own data, then you can either contact me at kilgourlab.com or speak to one of the team at SpectraSwiss. Thanks for watching.